Hey guys, welcome to question FM346 of the Further Maths Fortify study guide. This question reads, consider the following diagram, and then we're given this diagram here. We're told that the largest circle has a diameter of 25 centimeters. The second largest circle has a diameter of 12.5 centimeters. And this smaller circle has a diameter of 7.25 centimeters. Part A says, show that the length in centimeters of line BC is 34.59 centimeters when rounded to two decimal places. So we need to show that this length of this line here. To start this question, I'm going to start off by taking a right angle triangle that I can get some more information from. So we're going to take a right angle triangle between B, O, and C. The reason for this is because I know that line BO is going to be half of the diameter or the radius of this circle. So this is going to be 25 over 2 long, so 25 centimeters over 2 long, which is going to equal 12.5 centimeters. I also know that CO is, well, we can find what this length is between these two by taking the diameter of the small circle, the diameter of the medium-sized circle, and the radius length of the large circle, and adding them all together. So once again, we know that 25 over 2, or the radius length of this large circle, is going to be 12.5. We know that the diameter of this medium-sized circle is also going to be 12.5, because we're told that in the information we're given at the start. And we also know that the diameter of this small circle is going to be 7.25. Adding all of those together, we should get 32.25 for CO. So all of a sudden I know that this length here is 12.5, this length up here is 32.25, and the length that I'm trying to find is this BC. So I know two side lengths of a right angle triangle, and try and find a third one. So we're going to use our Pythagoras formula. So we've got c squared equals a squared plus b squared. A little rearrangement here. C is equal to square root of a squared plus b squared. And from here, we get that BC is going to be equal to the square root of 12.5 squared plus 32.25 squared. Plugging this into a calculator, you should get an answer rounded to two decimal places of 34.59 centimeters, exactly like the question was asking for. Awesome. On to part B. On to part B. Question B says, use the cosine rule to show that the angle theta correct to one decimal place is equal to 42.4 degrees. So the cosine rule that we're starting with is going to be cos of A, because we're finding an angle, is equal to b squared plus c squared minus a squared, all over 2bc. So a quick rearrangement to make this a little bit easier to follow. We should get A is equal to cos of b squared plus c squared minus a squared all over 2bc. And from here we've got to sub some values in. So B and C represent the edges that are either side of the angle that we're looking for. So since we're looking for this angle here, angle A means side A is directly opposite, so that's going to be this guy here. So our little a we're going to represent with 25, a value of 25. And then of course these edges, the two equal edges, we found the length of BC to be 34.59 before, and we're going to use that in here to find the angle. So we're going to replace our unknown angle with theta. And we've got cos to the power of -1 over 34.59 squared plus 34.59 squared minus 25 squared, all over 2 times 34.59 times 34.59. Plugging that all into a calculator should drop out an answer rounded to 1 decimal place of 42.4 degrees. Question C starts us off by saying triangles ABC and TSO are similar. Part C says, what is the length in centimeters of the line ST? Round your answer to the nearest centimeter. So the way that I've decided to go through this question is I'm going to say that since these two triangles are similar, the ratio of ST to AB, so the base of this isosceles triangle compared to the base of this isosceles triangle, should be the same as the ratio between this side of the isosceles triangle compared to this side of the larger isosceles triangle. So ST to AB should be the same as the ratio of OT to AC. So what I need now, since this is the value that I'm looking to solve for, I'm going to need to find the values of these others. So I know that AB, that length there, is going to be 25 centimeters. We're told that right at the start of this entire question. I know that OT is going to be half that value because the radius of this circle, so it's going to be 25 over 2, which is 12.5 centimeters. And I know that AC is 34.59 centimeters because we were told to show that earlier in this question. So I have these 5 values here, which means I can now plug them into my original formula. So I should get ST over 25 is equal to 12.5 over 34.59. Rearranging for ST, I should get 25 times 12.5 over 34.59, which, plugging that all into a calculator and rounding to the nearest whole centimeter, should give you an answer of 9 centimeters for OT here. Finally, question D says, what is the area in square centimeters of triangle TSO? This triangle here. Round your answer to the nearest square centimeter. Now in this question, I've chosen to use the rule half times A times B sine theta, because I know what these two side lengths are, and I also know what this angle in here is, because these two triangles are similar. It's going to have the same angle that we found before, 42.4. Now the only reason I'm relying on these numbers like 42.4 is because the question actually gave us those values. We know they're correct because the question said show that that angle was 42.4. So we can be very confident that this angle is 42.4. So plugging all these values in, we get half times, we know that OT and OS are going to be 12.5 centimeters each. So instead of writing 12.5 times 12.5, I'm just going to write 12.5 squared, means the same thing. And then we're going to get times sine of 42.4. Plugging that all into a calculator and rounding to the nearest square centimeter, we should get 53 centimeters squared. Cool. So if you guys have any questions about these questions, please drop them in the comments below. Otherwise, I will see you in the next video.